Okay, in this video I'm going to do yet another um, example problem in the realm of counting exercises, so basic counting problems. And in this problem we're considering passwords of length 3 made up of characters. At least one and at most two of the characters needs to be a special character chosen from a group of 11 special characters. The remaining characters, that is the non-specials, are either uppercase or lowercase letters. So there's 52 options for the non-special, for the letters, and there are 11 choices for special characters. And part A asks you to notate all the different possible types or classes of password that adhere to the rule that at least one and at most two of the characters needs to be a special character. Okay, so SLL is fine because we have exactly one special character. LSL is also a valid password category where you have a letter and then a special character and then a letter, and it has at least one special character. But 3Ls, 3 letters, does not adhere to the one that you have at least one special character. And at most 2 special characters, you couldn't have 3 S's. And so the possibilities for the types include those with either 1 or 2 out of the 3 characters of the password being special. So there are 3 cases where we could have one special character: LLS, LSL, and SLL. The special character could be the third one, the second one, or the first one. And similarly, when we have 2 special characters, we can either put the letter first, the letter second, or the letter third. Okay, so there's 6 possibilities of orders of special characters and normal letters in our passwords. Okay, and it turns out that, so part B asks us to use the product rule to calculate the number of passwords in each category. It turns out that those with one special character all have the same number of passwords in their category. So LLS, LSL, and SLL all have, each of those categories has 52 times 52 times 11 possible passwords in them. 52 for the choice of the first letter, 52 for the choice of the second letter, wherever it is in the position, and 11 for the choice of the special character. And if you multiply those out, I think you're going to get 29,744. Okay? And the other 3 also each have the same number in them. And that number is, so LSS, SLS, and SSL all have the same number, which is, well, now we have only one 52 and 2 11s. 52 times 11 times 11. 52 is the number of choices for the letter, and 11 and 11 are the choices for the 2 specials. And this is a smaller number, 6,292. And so the total number of passwords is then going to be calculated in part C using the sum rule to calculate the total number of valid passwords. And so what we've got is 6 different categories of, or 6 different sets of valid passwords. And so a valid password, the set of valid passwords, oh, for heaven's sakes, come on, is equal to the union of the sets of 6 sets: LLS, union P, LSL, union P, SLL, union P, LSS, where each set of passwords is given a subscript which indicates the order and number of specials and normal letters in them. And all 3 of these, or all 6 of these sets are disjoint, None of the passwords that's in one set could possibly be in any of the other sets. And when we take the union of these 6 sets, they add up to, the union is the entire set of valid passwords according to this rule. And so this is an example of a partition of p-valid. Okay? And when you have a partition of a set and you want to count the size of that set, you simply add up the sizes of all the sets that go into it. And we found up above in part B that 3 of those sets have a size of 29,744, and the other 3 each have a size of 6292. In any case, p-valid, the size of that set is the 29,744 plus 29,744 plus 29,744 plus, and then we get 3 of the 6292s. Plus 6292, and it turns out to be 3 times the sum 29,744 plus 6292. And the whole number comes out to be 108, 108. Okay, so that's a nice example, I hope a relevant example, counting passwords. And what we've done is we've used the product rule to calculate the number of passwords in each of these 6 categories. And then we've used the fact that those 6 categories form a partition. And then we can use the sum rule to add them all up. Okay, hope this helps. This is very much like one of your homework problems.